So also important in medicine when we deal with half-life is looking at dosage calculations, both to figure out the dose being given to the patient as well as how long they're going to be emitting a significant amount of that particular type of radioactivity. So when we look at our dosages, we're going to see a new unit here. And there may be a couple of different ones. The most common one we see is called millicurie. And this is just a way to measure the amount of radioactivity. We're not particularly worried about the meaning of those units, but what we see is that we have some way of representing the activity per unit volume or per unit mass. Most often it's given as volume. And so if we're told that a particular solution has an activity of 25 millicurie per 15 milliliters, that gives us a clue that it's giving off this much radiation from that volume at time 0. And so what we want to do is figure out what dose do we need to give to a patient. And so when we see this per, we know that means we can write it as a fraction. And so we're now got another relationship that we can use. Now this relationship will be just like molar mass or concentration in that it changes depending on the actual description of the particular medication. So you'll have to get this from the problem, but it's still used as a relationship. And do we generally start problems with a relationship or with a number with a simple unit? Right, we always start them with a simple unit. Let's look at an example, and we're going to use dimensional analysis as we've been using all semester. So a patient is given 18 milliliters of a treatment that has an activity of 35 millicurie per 100 ml solution. So we can write that as a relationship. What dose did they receive in millicurie? So now we have two numbers, one with a simple unit and one with a relationship. As we've done previously, we want to start with the number with a simple unit. So we say 18 milliliters, 35 millicurie goes on top because we need to have milliliters on the bottom to cancel out. So we can cancel milliliters, and we are left with our units of millicurie. So 18 times 30 divided by 100 gives us 6.3 millicurie. So these problems are solved no differently than any other dimensional analysis problem. What we're looking at is making sure that our units cancel out correctly.